So the IK constraint actually works on a chain of bones rather than just the one bone itself. So it's a little bit different to the other constraints that I've already shown you, and it actually requires a little bit of a setup. So I've just gone ahead and created a mock setup where you might see the IK constraint used, and that would be a leg. So here we've got a hip. You can see that's the parent of most of our setup here. We've got a thigh, we've got a shin, which is where we're going to add our constraint, which is why I've got the owner in brackets here. And then we've got a foot here, which is a target, and the knee pole over here, which is going to be a vector. Actually, I'll just name this just to help us out a little bit later on. Now, it's important to point out that this is just the basic setup for demonstration purposes. It's only the main mechanism behind the IK leg. It's actually not the complete setup that you would use in a real character IK leg. But this will make it easier to understand for demonstration purposes. There's actually two hotkeys to add an IK constraint. We can actually choose the bone that we want to add the IK constraint to, which will always be the end of the chain. So, and then we can hit Control-Shift-C and choose the inverse kinematics, and that will add our constraint, or we can hit Shift-I. And this is just a shortcut for the IK constraint. You can see here, add IK, and we've got two options. We can choose to add it to an empty object, which is going to create a target, but I quickly want to show you without targets first, because this is a really weird constraint where it can work without having a target at all. So I'm going to choose that. And over here, you'll notice that my constraint has been added. So this is a different color to the normal constraint, which is green. Now, the reason it's a different color is because it works on multiple bones at once rather than just the one. And that's why you can see this dotted line here going all the way up here to our hip. So the orange color actually represents that this is a targetless IK. And I know it's targetless because we've got no information over here. But if we grab this with the G key and move it around, you can see it's still kind of working the way that we would expect the leg to work, although our foot's not following and it's influencing our hip. So we can actually change how far it goes with our chain length down here. Now, when you add it, there's 0 here means it's just going to run up the chain as far as it can go. In this case, it's going to run up all the way to the hip. So if we want to limit that, we can actually change the chain length. So now you'll see that there's a dotted line that just goes to here, and let's just change that to 2. And the dotted line goes all the way to the top of the thigh. So if we grab this, this is kind of what we would want a leg to work like. And if we still grab our hip here, that's going to follow along. That's what the chain length does. Now, the use tail will actually kind of shift it up one spot. So you can see it's no longer taking over the rotation of our owner bone here. It's actually just shifted everything up because it's starting at the head of the owner bone rather than at the tail. But let me just re-enable that. And I want to show you why I don't think it's ever a good idea to use the targetless IK constraint for this reason. Because it takes over the rotations of all the bones in the chain. If I grab this and move it over here, it might be good, but then if I want to reset it back to normal, I have to clear the rotations, and that's fixed on that bone. But then I have to also select this bone and clear the rotations on this bone to bring it back to normal. And this is not a very good thing to do for animation. So for that reason, I would always suggest using a target. And that's really easy to do. We're just going to use that same constraint that we've already set up, but we're going to add the target. So we're going to click our eyedropper and click the armature object. And now because we've targeted that armature object, it says, hey, do you want to target a specific bone inside that armature? And yes, I do. I want to actually target the foot, which I've called foot, and then in brackets, target. So now you notice it's gone yellow. And this would be a normal IK constraint. So now we no longer grab this guy here. We actually grab the foot control and move it around. Now the advantages of this is you can rotate and position it anywhere that you like. And then you can clear the translations and rotations on the foot, which is the target, and the whole chain is going to reset. That's why I would suggest using the actual targeted IK. Okay, so we've still got some more targets down here. If we wanted to control the knee here, we would actually position it wherever we want, and then we would actually rotate this guy up here to move our knee. And that might not be very helpful for an animator to do. We can actually control this using a pole vector target. So let's just target our object again. So I'm just going to use my eyedropper, and then you'll notice that it's kind of broken everything, and that's because it doesn't have a target here and the constraint is confused. So we're going to target the bone, which is going to be our knee pole vector. So let's just choose this here, knee pole vector. And you can see now when I move this bone around, that is how I control where the knee would be. Let me just reset everything back to its default positions and talk about the pole angle. So at the moment, 0 degrees, it's pointing this bend towards that knee vector. But if that happens to be wrong, we can adjust this with our pole vector to -180 or +180. So that's what our pole angle will do. Sometimes you just need to offset this a little bit to keep it straight and working the way that you want. Now the iterations is going to be the solving iterations. So the higher the number, the more calculations it's going to do to try and position these bones where you tell it to. And the lower the iterations, the less calculations it's going to do. But in my experience, you can just leave that at the default. I've never had to touch it. Now with this stretch enabled, you would think that you can just grab our foot and then keep it moving and these bones will stretch. It will do that, but you need to enable stretching on each bone in the chain. So it doesn't matter which one that you choose first, but those settings are over here in the bone tab. We're just going to scroll down to the tab that says inverse kinematics. And here we've got IK stretch. At default, it is 0, which means no stretching. And I think it goes all the way up to 1. But we really don't need to go that far. Let's just go 0.1 and you'll see that it's going to stretch to that target. But now we've got a really big bone and the thigh bone's not stretching. So let's do the same thing. Make sure that we choose the same value for both of them. Then they're going to stretch the same amount. So now you'll see that when it gets past that point, it's going to stretch, although it does scale on all axes. So this might be something that we need to work around if we're doing deformation on our rig, which we should be, to stop the legs getting absolutely massive when we stretch like this. Now, when we set the limit to 0.1, that means we can go to a certain point and it won't go past there. We can actually keep it stretching if we raise this value, let's say 0.2, now it's going to keep going. But we also need to make sure that we keep them in a similar range because now the shin is going to stretch more than the thigh. So let's just do the same change and you'll notice that they're now both equally stretching. Let's reset everything there and have another look at it. So there we go. Now there's some more settings that you can do. You can actually lock the axes that you don't want to spin around. But now you notice I've locked all the axes. It's going to behave in a really weird way. It's just going to go, I can't rotate towards that. So I'm just going to shrink myself. So make sure you don't lock all the axes. So here in our stiffness values, we can actually make it more stiff, so harder to rotate on these particular axes. So you can make it stiffer on the X or the Z, and then that's going to affect the way that it's going to rotate. Although you're not going to see much of an effect with this simple IK chain with 2 bones in it. I usually don't worry about changing the stiffness. I usually just leave those at the default 0, so I know that it's going to rotate on all 3 axes evenly. And you can also limit how much it's going to rotate. So here, our x-axis, it's going to rotate 180 degrees in the negative and positive, which means 360 degrees essentially. But we can actually change that. So we can slide this down. You could say it's only going to rotate that way. And you can do the same thing with all the 3 axes. So we can lower it down if we want. So now it can only rotate in that realm. Although I haven't found any real need for these settings, so I usually don't limit any of the axes at all. And the only other 2 things here are the weight position and the rotation. So by default, this is checked on and it's going to follow the weight position by 1. So this is going to try and reach the position of our target. That's what the weight position is. And if we disable this and turned on the rotation, what that's going to do, just reset this, it's actually now acting like a copy rotation, although it's going to work its way up that whole entire chain. So before I draw this lesson to a close, I'm going to show you some of the common mistakes or things that get confusing when you first try and use this constraint. So the first problem will be, well, let me just add an IK constraint. I've just added the bone there, and something crazy like this is going to go on. And that is because with the default setting, your chain length is going to go to 1, and it's going to go all the way up the hierarchy. So just be careful when you add it. The first thing that you need to do is make sure that your chain length is correct. In this example, I only want the chain to go up to here. The next problem is going to be something like this. So I'll just reconnect that, make sure that my chain length is correct. And then I'm going to grab this bone here, which is my target, and then try and move things around. And it goes, oh, what is going wrong? And that is because this target bone cannot be part of the same chain here. So this bone here cannot be part of the chain that is being influenced. Otherwise you have a dependency cycle. So I'm going to clear that with Alt-P and then say clear parent, jump back into pose mode. And now you'll see that IK constraint is behaving the way that I want. Another common problem is going to be when the legs here are straight. So let me just show you. I'll add my constraint to make sure my chain length is correct and then try and move it around. So our knee here is going a little bit wobbly. It's trying to do the right thing, but it can't quite behave properly. And that is because this leg is dead straight. So the IK constraint is going to really struggle to try and find a solution where to put these bones in order to reach the target. So a way to counteract that is to always put a slight bend in the knee in the direction that you want it to move. So that way it can solve correctly. And our final problem is one that I've already mentioned before. I've just gone ahead and created a pole vector for this one now. So I'll just enable my IK. You'll notice that the knee is bending in the correct direction, but then when I enable it, it's kind of flipped around and it's a little bit wonky. And that is because of the roll of our bone. We've got the Z-axis pointing backwards and the X-axis pointing out here. So what it's trying to do is point the X-axis towards our target here. So this is what we can change with the pole angle. So we can just change this to be -90. So type in -90 here. So now when we move our knee, it's actually the direction that we want. So hopefully that has demystified the IK constraint for you and solved a few problems that you're likely to run into.